Cool. Oh, sweet, we got before. All right. I apologize for being late. I teach private violin lessons, and she really, really wanted to learn dreidel, and we got a little distracted, so I apologize. But now that we're here, we can talk a little bit about sexual dimorphism and how biologists and paleontologists use that to determine the sex of animals. So, sexual dimorphism is the condition where males and females of the same species exhibit morphological differences. The most obvious differences we think of is ornamentation and colors, which I do not think I can show you. If I can, I don't know. But imagine things. So many species of birds use this method. We're used to birds being our most obvious forms of sexual dimorphism. Males have flashy, colorful breeding plumage. Think about ducks, peacocks, and other game birds. You can think about birds of paradise, parrots. Not all types of parrots, but some types of parrots do have differences in their plumage. Lots of little birds like warblers and wrens have flashy plumage as males. But birds are not the only ones who will use flashy colors. The Lasurus frog will utilize color differences as well. Males become more yellow during breeding season. Male betta fish are more colorful and have larger, flashier fins, which is great for getting the ladies to notice you and terrible for swimming purposes. They're not great swimmers. I feel bad for them. Other types of ornamentation can be seen, such as antlers in our deer and our elk, horns like pronghorn, tusks like in pigs and elephants, and manes like in lions. These are used to both attract females and for competition with other males. Yes, manes in lions are used as competition points with other males. The darker the mane, the more likely a female is to breed with you. Fun fact. Animals are also not the only organisms to display sexual dimorphism in this way. Plants also do. Most plants have both male and female parts, but there are some completely separate organisms. Examples include the papaya plant, holly, ginkgos, and cannabis. One plant, the catasetum orchid, the male flowers attach to bees quite violently. And because of this, the bees will tend to avoid other male parts of this plant, or male plants, I should say, and will look for the female ones instead because they look different and don't come across as the same plant to the bees, and therefore propagate breeding. Insects will also display ornamental sexual dimorphism. Certain kinds of male beetles sport large headdresses. Some male butterflies are vibrantly colored. Some spiders, like jumping spiders, the males will have very colorful bodies, and they'll do little dances for the females. Other forms of sexual dimorphism include those ritual dances, songs like in birds, size differences, and even cannibalism, which is mostly seen in spiders. So, along the lines of size is another character seen in a lot of animals. Many animals like moose, elephant seals, beetles, lizards, and game birds have much, much larger males than females. In fact, that is one of our sexual dimorphic characters as humans, is that males are typically larger than females. In animals like spiders, raptors, frogs, turtles, and deep sea fish, females are actually larger than males. So to circle into our fossils, fossil ammonites like Bipheraceras display this kind of sexual dimorphism, with females being substantially larger than males. Now, other than ammonites, are there other fossils that exhibit sexual dimorphism? Yes. Let me get my notes. Pterosaurs are a great example. Some males sport a large crest on their heads while the females don't have a crest at all, while others like Nyctosaurus or Pteranodon, both sexes have crests, but the males are much larger and flashier. I know a lot of people ask about sexual dimorphism in dinosaurs and want to know if we can tell male and female dinosaurs apart. No. Our male and female dinosaurs, there really isn't a foolproof way to tell. There's been a lot of talk and speculation about medullary bone, saying that the B-Rex had medullary bone and all of this stuff. The thing is that you can only get medullary bone if you are in the process of getting ready to lay eggs. And so it's unreliable to depend on looking for medullary bone, because it's just not going to happen that often. And number two, there's a lot of controversy around the medullary bone and whether it's actually medullary bone or something else that you can find in there. There isn't. It's too controversial to say. We don't have a definitive way to tell with our dinosaurs. And we can't use, hey, we found this one with a nest, because look at their living relatives. There are plenty of birds, ostriches, emus, phalaropes. The males are taking care of the offspring. So for all we know, males were taking care of the offspring in some species of dinosaurs, and females were taking care of them in others. Or some of them might have had both parents involved. We just don't know. There's no way to tell. So unfortunately, dinosaurs are not one of the ones that we have sexual dimorphism noticeably in, at least. But we do have some fossil mammals that are possibly displaying sexual dimorphism, such as Megacerops. There's a robust form with bigger horns on its nose, and there's a gracile form that has more slender horns on it. So it could be showing male-female. But aside from that, the fossil record, it's hard to tell how much sexual dimorphism we could be seeing, because you need to have a certain number of specimens in order to have a good group to look at this information. And unfortunately, with a lot of prehistoric animals, we just don't have the numbers. Ammonites, that's easy. We have so many ammonites. So it's easy to be like, hey, this one's probably male, this one's probably female. Whereas with dinosaurs, we're lucky if we have, 20 specimens of any given dinosaur out there. And we just can't get the numbers we need. But other than that, that is my talk on sexual dimorphism. I will post a short that just kind of shows pictures of the different animals that I talked about, so that you guys can get a visual on what the sexual dimorphic traits look like. So keep an eye out for that, and hopefully we'll see more of you on the next live. I'll try to do this on Saturdays, maybe not at 5. Clearly my lessons are interrupted, but maybe it's 6. We'll try 6 next week. How's that sound? All right, I'll fossilize you guys later.